Hi, in this video we are going to explain the physics behind a yo-yo. I'm Amina.
I'm Kailey.
And I'm Jenna, and we are the Quantum-plators. So what is a yo-yo? A yo-yo is a toy that is made up of two discs with an axle connecting them. There is a string wrapped around the axle. Because the string is wrapped around the axle, the yo-yo is forced to rotate as it moves downward due to the force of gravity acting upon it. Yo-yos are the perfect demonstration of how potential energy is converted to kinetic energy. When the yo-yo is at the top and wrapped around the axle, it has potential energy. It contains potential energy due to its position above the ground and also due to the fact that the string itself is wrapped around its axle. When it drops to the bottom, all of that potential energy has been converted to kinetic energy. The yo-yo has the most kinetic energy right before it reaches the bottom because that is when the angular velocity is highest.
Another concept involved in the physics behind a yo-yo is momentum. So what is momentum? It is defined as the quantity of motion of a moving object. A yo-yo displays both linear momentum and angular momentum. So linear momentum is the product of mass and velocity, and this is shown when the yo-yo moves up and down. And angular momentum is the product of the moment of inertia and the angular velocity, and this is shown when the yo-yo spins around, as seen in the video to the right. Another concept involved is torque. It is the measure of the force that can cause an object to rotate about an axis. So this is demonstrated with the equation torque equals R times F. R is the distance from the pivot to the point where the force is applied, and F is the force. So you can see how rotating a yo-yo differently can change the direction of the torque. In A, pulling the string vertically creates a torque R1F rotating the yo-yo counterclockwise, while in B, pulling the string horizontally creates a torque R2F rotating the yo-yo clockwise.
Another factor involved with the motion of a yo-yo is rotational inertia. Rotational inertia can be defined as an object's resistance to change in rotating motion. That would basically be, if the yo-yo is spinning, it's going to stay spinning until a different force acts upon it, and if the yo-yo was at rest, it would stay at rest unless another force acted upon it. The equation used for the rotational inertia of a yo-yo is shown on screen. It is I equals 1/2 mr squared, I being rotational inertia, mass being mass of the object, and r being radius of the object from the axis of rotation. Circular objects of different shapes will use different equations to solve for rotational inertia. When the yo-yo is fully released and the string wrapped around the axle runs out, the axle will keep spinning due to inertia as mentioned before. This will cause the string to wind back up in the other direction, and the yo-yo will rise again. The more mass that goes away from the axis of rotation, the greater the yo-yo's moment of inertia. Frictional force is used to stop a yo-yo if the hand of a person playing with it does not interfere before enough time has passed. And this can be explained with the belt friction equation. The two T's are the tensions of the string wrapped around the axle, T2 being the larger tension and T1 being the smaller tension. E is Euler's constant, which is raised to the power of the coefficient of static friction between the surface and the belt, and the angle of contact in the unit of radians.
Thank you for watching our video! We hope you learned a lot about the physics behind a yo-yo.